So we're going to start solving linear programming problems by using a different method, and it's a method that doesn't require graphing. It's called the Simplex Method. And the Simplex Method uses matrices. Now, one thing you might remember about matrices is that they're used to model systems of equations, not inequalities. So we're going to have to make some adjustments to make this linear programming problem look like a system of equations, and then be able to use matrices. But step by step first, when can we use a simplex method? Well, simplex method is used to solve standard maximization problems. So the objective function has to be maximized. And as you can see, this one is set up that way. Okay. The coefficients of all the variables, notice I'm using x1 and x2 here instead of x and y. Normally for simplex method, we use subscripted variables just so we can keep track of them, because the simplex method can be used for situations where, there's no limit to the number of variables. So there could be one where there's 15 variables, okay? So we're just using x1 and x2 as opposed to x and y. There's nothing wrong with using x and y though. But notice that the coefficients of the variables are positive, okay? That's a need to know, that's a need to have in a simplex problem. The other thing about them is that the constraints all have to be facing this way. So notice that the coefficients of x1 and x2, again, non-negative, they're all less than or equal to constraints. With the exception, of course, of these, which remember are called the non-negativity constraints. So we have to assume that x1 and x2 are non-negative. Okay, so now getting to the equations. So think about the optimal solution. The optimal solution may or may not use up all the constraints. So in other words, let's looking at the first one. If I tell you that x1 plus x2 has to be less than or equal to 100, that means that it's possible that the optimal solution maybe only uses 90 total. Maybe it's x1 equals 50, x2 equals 40. So what we have to do to make this an equation is to allow for extra space. And what we call that idea is a slack variable. And we need to introduce a slack variable to each constraint. So the z does not get a slack variable, it's an equal sign. So I'm going to write x1 plus x2 plus something, and I just want things to line up, so I'm just going to put the equals over here. So the slack variable I'm going to use, and again, it's a non-negative number because, again, we're talking about x1 and x2 possibly be smaller than 100. So we have to add another positive number, or at least non-negative, into the mix. I'm going to call it S1. So for the second constraint, I'm going to say 2x1 plus 3x2. Now I can't use S1 again because that's reserved for the first one. I'm not guaranteed that these variables are going to be the same value. So that's equals to 240. And then we have x1 plus s3 is equal to 80. Now, the other thing is that this table, these equations, they all have to kind of work together. And z is also a variable because depending on what values of x1 and x2 we use, z is going to change. So I need to write an equation for z. Now, in order to keep z positive, I am going to take this equation right here, and I'm going to bring x1 and x2 to the other side. So that means I'm going to have negative 14x1 minus 17x2 plus z equals 0. Okay, so there is our list of equations. Okay, and again, we did that so that the z could remain as, just like S1, S2, and S3 has a coefficient of 1. So now looking at this, I'm going to now create the initial simplex table. But I'm going to make a heading that keeps track of all of these variables because there is just so many right now. And I'm actually going to call the other side of the equal side. Remember, the augmented matrix had the vertical line. I'm going to call it right-hand side, RHS. And I'm just going to write in the coefficients. So the first line is going to be 1, 1, 1. 0 is the rest of the way until the 100. And then I'm going to have 2, 3, 0, 1, 0, 0, 240. 1, 0, 0, 0, 1, 0, 80. And for the bottom row, and this is the weird row, negative 14, negative 17. No slack variables in the objective. The coefficient of z is 1, and I am at 0. Okay, so when we come back, we're going to learn how to read this table as far as what the solution is telling us right now. And then we will see how to get to the optimal solution. So please stay tuned.